I'm Raffaele Dall'Oglio. I'm a Be Good partner from Italy. I'm a beekeeping consultant, small, medium enterprises in this project. And actually, this is not my role in the project, but today I'm presenting you some single origin honey from Italy, but these are also common in Europe. For instance, lime, sweet chestnut can be produced also in other countries. Maybe dandelion, acacia are more typical for our region. And we also run, we have in Italy a register from the Ministry of Agriculture about honey sensory expert. I'm also member of this register, and I'm also a teacher for the register, and we run classes about honey sensory analysis. So we provide education on honey quality, about how to avoid putting on the market defective honey, and how to recognize by using your smell and taste the different botanical sources in honey. So this is useful both for beekeepers, but also for inspectors, chefs, sommeliers, foodies, whoever is willing to improve their skills.
People miss who you are. Actually. Yeah, no, that's why we introduced it now. And I see we have a question on the chat to Raphael. One moment.
Let me see if I can open it. So yes, Raphael, the question is there any specific honey sampling technology developed in Be Good to improve honey testing?
Well, luckily enough, the electronic nose that we have so far are not that powerful as the human nose. So we still rely on human control, on the quality assessment for the sensory definition. But I have to say that most of the analyses are run also in the lab for pollen counts and so on. In Be Good, actually, we are not tackling honey quality. We are not tackling this kind of topic. So that was part of this informed market, just to give you the idea about what is possible to do and how to improve the value of your production through increasing the quality and through creating differences in your shelf.
Thank you. Thank you.
I think we make a good team, so maybe we can go together to stands.
Yeah, sure.
I will live stream and you can ask probably questions, and I will monitor the chat.
Yes, that's good. So I think we can go to this stand. What have you got to show here?
We have lateral flow devices for the detection of neonicotinoids, so pesticides. So they are tests where you can test yourself with a simple extraction with some water, hot water. And you get an answer in 15 minutes if neonicotinoids are present in your leaves or your flowers or your honey, nectar, whatever you want to analyze.
And why is this an important part of the program?
This is an important part because this is where you actually take diagnostics, as nowadays you know by a simple COVID test, that you can take it directly to the beekeepers where they can perform tests themselves to see if there are pesticides present in the bee environment.
So there are a few questions in the chat. One is all neonicotinoids. All neonicotinoids can be tested by the device?
This test can detect 7 out of 8 neonicotinoids. So before we used to have this test where we had 2 channels, and this is a separate one. And now they are combined all together in this 3-channel strip test. So we can detect 7 out of 8, which is almost complete.
So this is a bit hard from the phone. How do you prepare the solution that you put on the LFD?
So the solution, you take 2.5 grams of the material that you want to analyze, and then you add 10 ml, 10 milliliters of boiling or of hot water. Then you shake it, you leave it until it cools down, because the test you cannot apply hot water. So you let cool down the water, and then you can take 2 drops and you apply it into the test.
I think we have one more. What about new neonicotinoids? So Foxafor and Fopiradiforon?
Well, I don't agree that they are new neonicotinoids. I think they replace neonicotinoids. They're very popular at the moment. So there are no tests yet for that. But however, we have the antibody and the conjugate that we need to develop a test for sulfoxaflor. So this was not mentioned as a target pesticide in the Be Good project. However, if people are interested, we do have the materials to develop tests for sulfoxaflor as well.
Okay.
Thank you.
Thanks, Jeroen.
Okay. Can we ask you some questions? What have you got to show here?
So we are work package 1, and we work on tier 1, tier 2, tier 3 on data harmonization and collecting data and communicating with beekeepers. So that's what we do in work package 1. So we basically feed the data into the project.
And yeah, well, that's actually an obvious question, but why is this important part of the program?
Well, it is one of the main parts of the program, I would say, to provide the project with data. And we collect data mainly on bee health indicators, so from the colonies. So it's an integral part of the project.
And I see you even have bee earrings. Oh, oh, unfortunately.
But
Okay, one question we have from Noah. What are your experiences in data standardization when you record the data?
sorry, again, Theodore, I could not
What
hear.
are your experiences in data standardization when you record the data?
Data standardization. Well, for the Be Good project, as has been mentioned today, it's like a three-tier approach. So in the beginning, there was a lot of work on like data standardization and also gaining input from all the researchers and beekeepers also in tier 2 to improve methods and help with standardizing data. Not sure if that's a satisfactory reply, but
We'll see. Noah, if this answers your question, or if you want to elaborate more, please feel free to use the chat.
we also based our protocols on previous research. So in the beginning, there was a lot of course, like deep diving into what is already being done in bee research. And on top of that, we kind of progressed and improved the methods within the project by applying them in first tier 1, tier 2, and then finally, of course, tier 3.
Okay.
Yes.
Thanks, Zeynep.
Okay, then we're going to continue. Oh,
One. Have you experienced that the data providers have increased the quality of the data collected? I think a word is missing.
Again, the data providers have increased?
Have increased the quality of the data collected.
I think so. I think beekeepers are very nicely open to feedback, and we've seen that people have been providing better data, and in like we've also improved the Beep app together with the feedback of researchers and also beekeepers. So in time, I think from both ends, we've firstly made it easier to enter data, and by giving feedback to beekeepers, we've seen that their methods of entering data have become better. So in time, I think from both sides, we have improved.
Okay, thank you. Thanks a lot.
yes. Oh, one more question or not?
No more questions currently.
Okay.
Noah
Thank
says
you.
thanks.
Hello.
Hello.
What have you got to show us here?
Show you is actually an insect camera. It's not completely focused on bees, but we make a camera which you can use to make photographs of insects. Normally you use a sticky trap, but then you kill your insects and you have to go there every day or bi-daily. And with this camera, you can just put it in the fields and yeah, you can leave it there for 2-3 months and it will make pictures of all the insects it captures. And insects will be, pictures will be sent to Naturalis Research Museum in Leiden. And they will do photo recognition on the insects, so you know what kind of insects are there on a specific place.
And why is this an important part of the program?
I don't think it's really completely part of the program, but we worked a lot.
Why is it important for the beekeeping community?
Beekeeping, because it gives you an insight in how insects are living, and bees are part of this environment, and you need all insects to have a healthy environment and a healthy climate. So that's why it can be important for beekeeping. So it's more a broad perspective of all insects.
And did you invent this?
actually Naturalis invented it.
Mhm.
And we made a second version, and they looked for somebody who could produce it and maintain it and update it, and then that's what I'm actually doing. So yeah.
Yes, we have one question. What is the range of this camera and how do you make the insects get to the camera?
Sorry, what was?
What is the range of the camera and how do you?
I
How
don't
do you
know
make
what the
the
range
insects?
is. It depends where you put it, because if you put it near to the woods, you will get different results than when you put it in the field. And how do you attract insects? The screen is yellow. That's a quite common color for sticky traps. It will reflect sunlight in UV light, and you also have during the night, when you collect the most insects, there's UV light in it and just a normal source of light, which is enlightening the yellow plate.
All right. And I'm not sure, did we miss the introduction for this one? Did you introduce yourself?
No, I
And
did
your
not.
role? Please do.
I'm Stefan Petersen. I'm the owner of FaunaBits. I'm also working for Beep. And this is another project from the same group of people, and I am the main keeper of this product.
Cool. Thanks.
Who are you and what is your story?
Who am I and what is my story? Yeah, hi, I'm Martin. I'm from Northern Germany. And my story in terms of what we're just talking about is that especially for new beekeepers, I think having a hive scale is extremely valuable because it prevents you from actually looking into the hive 20 times a week because you're so utterly curious about is everything going okay or not. So I was just referring to last year in May, it was extremely cold. So folks had their hives put into the rapeseed fields. And the issue was everything was blooming, bright yellow, and everything looked nice and shiny, and you just expect the bees to find food. Reality was daytime temperatures were under 10 degrees, so rapeseed doesn't produce any nectar. And effectively, it's like a big, nicely looking yellow desert. And I had my colonies on a hive scale, so I basically could inform folks, look at this, you are in trouble, please check your food supplies. And that's what they did. So hive scales are cool.
And is that also what we have here, April?
So this is the Beep base, which is a hive scale that we produce at Beep. And you can see we set it up here with the, I think you already looked at it with the camera, right? Yes. Yeah, Theodore has been filming it. So this is the Beep base, and you can see attached to it this box, which is actually a way of attaching more temperature sensors to the Beep base because it measures weight, temperature, and sound. And the information is sent to your Beep app. And in the Beep app, you can see how your bees are doing. So that's basically what the Beep base does. And I can show you here in the setup if you want to. This is a hive with the Beep base underneath. And here is the temperature sensor, which you can put between the frames of the Beep base or of the hive. And then the microphone goes in the middle on the bottom of the hive. And that's the way we set it up for BeeGood. And if you then put your Beep base on 15 minutes intervals, you will get all the data that is then used in the research. So we try to make it as uniform as possible. So with this setup, everybody sort of gets the same data out of the...
And what do you mean with 15 minutes interval?
Well, the Beep base works in a way that every 15 minutes it turns on, and Laura makes connection with the cloud. And when it turns on and it makes connection, it takes a measurement in that moment. And so it turns on every 15 minutes, makes a measurement, turns off again, or sends the data, turns off again. And that's the way you can use it for a long time without the battery depleting. So it's actually an energy safe way of making connection. And yeah, so that's how it works.
I'm gonna have a look at Theodore whether there are questions in the
there is
chat.
one, but just give me a second because. So again, from Noah, several questions. First, how many colonies do you have? Do you migrate with the scales, and what problems have you observed?
Well, I don't have any colonies myself. I'm not a beekeeper, but I work at Beep. But there are beekeepers that indeed use the scales and take them with them when they move the hives. So that's all possible to do. The only thing is it's important that you have a LoRa connection wherever you place the bee base, and that's one of the more difficult parts because LoRa is quite a new way to make connection, and like it's quite a young network, and therefore you don't have coverage everywhere. So that is one of the challenges that we face.
Okay.
Yeah.
Thanks, April.
You're welcome.
No further questions to
No
April?
further questions. Just a clarification that actually this question might have been for you.
Oh, go back to you. There was, how many colonies do you have?
Currently 4 in production and another 4 basically split off, so 8.
8. Yeah?
No further questions.
Then we go to the next, and thank you. Thanks
Thank
a
you.
lot. So we did see the honey. Let's have a look what happens here.
A physiological status where she's getting ready to lay an egg. So this is a laying worker bee. So if you get this too often, and sometimes you can get 1 a minute, 2 a minute, then your colony is developing worker bees who are laying eggs. Your queen is failing, or your queen has died, or you have had a queenless colony for too long if you get too much of that signal. If you get 1 signal a day, 2 a day, no big concern. But if you get too many of it, your queen is failing. That's a forager worker pipe. So you see the frequency is modulated. She goes like a sheep. And that's a bee that has found an extraordinary source of food, and she needs to regurgitate her food to another bee, and she's calling another bee to regurgitate the food to pass it on to another bee. And then we have the bee purr. This is like a cat going purr, like a cat on your lap. Purr. And this very, very frequent, very common signal, never published, and we don't know the function. And this is a third signal we are working on at the moment. And we write software. We pick up these signals. I can play you a few of the signals. And we are splitting the signals in 3 categories. This is not an academic exercise. This is actually our data. And this is the quality of the splitting that we can do. So we can easily split the forager worker pipes, the beeper, and the laying worker pipes. They can easily be split apart because the signature is very, very different. So we pick up a signal. That's the signal. We make this image, that image, and these images, they are very, very specific to this signal. So if you have a laying worker pipe, you're expecting the straight lines. If you have a forager worker pipe, you're expecting the wobble. And if you have a beeper, you have this pulsed signal, puff, 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 puff. So yes, I can show you.
We can first have a look here. What do we see here?
Hi. So we brought to look under the microscope some bacteria that cause American foulbrood, the bacteria that cause European foulbrood, and the spores of the bacteria that cause American foulbrood. And Mark also brought Malpighian tubes, which consist of Malpighium
Yeah, we also brought some pictures of like Malpighi amoeba, which is a disease that we knew invented in BeGood. So that the method that was used is very time consuming, and now we have a molecular method to use. And like, especially in BeGood, we want to take all the results on the diagnostic part together with all the results that we get from the bee base and everywhere to see if there are some like correlations, to see if we can have maybe special sounds or special gas in the colony when there is a disease present, and to give an alert if there is a disease present. So that's the idea. And here in the stand, we have just information on the results that we already had for lab analysis and some basic information for beekeepers that is coming from the European Ref Lab for the small hive beetle. We have some examples here of the small hive beetle adult and the larva to show to the beekeepers. We have some Vespa velutina samples here to show to the beekeepers. And yeah, we made up some informational material that can be looked up if somebody has an interest in a special disease. And yeah, we are here to answer all the questions of the beekeepers.
Great, thanks. There are no questions in the chat yet, but maybe we skipped a round of introductions. Of course, the consortium, we know who you are, but maybe you could briefly introduce yourself, Mark.
I didn't get you.
If you could maybe briefly introduce yourself, because we started, yeah, from the second half of it.
I'm Mark Schäfer. I work at the German National Ref Lab for bee diseases, the Friedrich Löffler Institute. And I'm in BeGood together with Severin from Belgium, from the Belgium National Reference Laboratory, responsible for all the laboratory analysis of the diseases that we are looking for in BeGood.
Great. We have one question. Mark, how is the Aethina evolving? Any news at EU level?
I didn't get it.
How is the Aethina? Maybe I spelled it wrong.
The Aethina evolving. For the EU level, there is no news. So it's still just Italy, just south of Italy, just Calabria, and occasional findings in Sicily. But Sicily should be free now, and it's just Calabria, and no new regulations from the EU side.
Okay, thanks. No further questions.
No
or
further
remarks.
questions. Okay, thanks a lot.
Thank you.
Then we're gonna have a next try to interrupt.
Maybe we'll get a chance this time.
Yeah.
Martin has a very cool research. It's fundamental. It's
What do we see?
Well, you see a queen tooting, but you don't want to watch the queen. Don't watch her. Watch the worker bees. The worker bees freeze. Look at that.
Yes, yes, that's
fantastic.
it. Yes. Okay.
And she's going to do it a second time. And it's very funny because you see the worker bees turn their head and they stop. Each time she toots, she stops. She's going to do it a second time now.
Yes.
Look at her.
Yes.
What are we looking at?
You're looking at a virgin queen broadcasting to her colony that she is mobile and that she is ready to swarm. And so we think that the worker bees are picking up that signal, and it stimulates the worker bees from keeping the other queens captive. So there are multiple queens in the colony, and as long as this queen is injecting that signal, the worker bees are keeping the other queens captive in their cell. We think this is what we are watching. But
This is something you're researching right now, or?
Yes, that's right. But what was entertaining our guest is our friend has highlighted a feature where he's absolutely right, is that when the queen is tooting, The worker bees are frozen. They freeze on space. You're absolutely right.
I made the same this week because it was just to show our customers that look over there. There is a new queen. She's tooting or teething or whatever, but tooting. But you see that the other, and the second thing I saw, the other bees are standing still, and it's and it felt for me like, okay, there is a kind of exception, but I don't know it's right. If it is a
common phenomenon.
what she is saying, what she is saying now.
We think she's telling the worker bees to keep, keep the other queens captive. Those that are quacking, quack, 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 keep them captive. Why? So that one queen is released at a time. It's for an orderly fashion to release the queens one at a time. And you maximize the swarms. You maximize the chances of survival because there will only be one queen capable of swarming. And when she has swarmed, there is no more tooting, and the worker bees realize there's no more tooting. We can release a quacking queen. And they release one quacking queen. She starts tooting, and this way you have one queen released at a time. We think that's the phenomenon.
And is that something you're doing research on? If this is for our online participants, can you maybe say your name and what your research is about?
Sure. My name is Martin Benchik, and me and my team, we use the measurement of the vibrations taking place on a frame in a honeybee colony to try to give information to help the beekeeper take decisions about his management of the colony.
That's why this morning you were so enthusiastic about vibrations.
Indeed.
Okay, and now you're showing at the stand the results or the things you recently found.
Yes, we published this last year or 2 years ago, I can't remember. And it's to do with our interpretation of the meaning of the tooting and the quacking. This gentleman was asking me, why is she tooting? And it's a very, very old question in beekeepers. Beekeepers have heard queens tooting and quacking, and everybody's wondering why? Why are queens tooting and quacking?
And how did you find out that it possibly is what you were just saying?
Yes. So our publication shows that each time you have a swarm, of course, the tooting stops because the queen has gone with the swarm. But that's not exciting. What's exciting is that after the absence of tooting, 3 or 4 hours later, you always have a new toot, always. So what's exciting is that we have multiple measurements of absence of tooting, resulting in tooting 3 or 4 hours later. So this suggests that the absence of tooting is telling the worker bees to release a new queen. It's not proof of it, but it's a suggestion. The actual proof would be to let a secondary swarm take place. There is no more tooting queen. And what we should do is then to drive an artificial tooting with a speaker, which is whoop, 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 whoop. And if I am right, the worker bees will keep the queens captive. There will not be a queen released for as long as they can keep her.
Will that be an experiment for the future?
Yes, absolutely. Absolutely, yes.
Are there any online questions?
Actually, yes, several. So let me just scroll up. One from Noah. Hi, Martin. Did you confirm what we observed on the movement of the bees within the hive with your new recordings?
Could you repeat the question, please?
Yes. Did you confirm what we observed on the movement of the bees within the hive with your new recordings?
So I think, I'm not sure what Noah means to say. I think she means to say this immobilization phenomenon. So this, the bees that are immobilized by the tooting, you can do it yourself. You can drive a vibration, I do it. You can drive a gentle vibration and you can freeze the bees. So this is something we do within Be Good. We freeze the bees for 1/10 of a second, so a very short amount of time. We freeze them. And we see the buzzing of the bees decrease because we freeze them. And so you could think it's a fun experiment to do, but what is the point? So we think that by freezing the bees and by measuring the buzzing decrease, we actually have a measurement on the mobility of the bees. So if the signal does drop, then your bees are mobile, they were busy. If your bees buzzing does not drop, that's because, like in the winter time, they were not mobile anyway. So we think we have a measurement of the mobility of the bees without having to open the hive. You can just find out if your bees in the box are mobile or not, and to which extent are they mobile. So I'm not sure I've answered Noah's question, but hopefully that was her question answered.
I think there are other questions, but there's like a clarification for her. The bees moving from one frame to another and coming back every 24-ish days.
Can you repeat that for me, Theodore? You're Theodore, aren't you?
Yeah, exactly.
Yeah, yeah.
Let's have a collective, because I might be misinterpreting. This is her original question to you. And then at the very bottom,
So I think I've answered that.
Yeah,
hopefully. And the next one?
This is a clarification, I think.
The bees moving from one frame to another and coming back every 24. Ah, she talks about the brood cycle.
Mm-hmm.
I think she's talking about the brood cycle. So at the time I was working with Noah, this is a lady I know very well. At the time I was working with her, we published another paper. It's to do with the fact that the vibrations we measure on the frame, they are very much decreased when the frame is heavy. So your cell, as I told you, your cell can be empty. It could have pollen, it could have honey, or it could have brood. So there are only 4 different states your cells can have. And an empty cell will vibrate much more than a frame that has brood or pollen or honey, particularly the honey, because it's heavy and it's more difficult to vibrate. So we published a few years ago the fact that we can actually pick up the brood cycle, the queen laying eggs, because the frame is then very light, and then the eggs grow into larvae. The frame becomes a little bit more heavy, and then adult bees. And then when the adult bees are born, you have an empty cell for 1 or 2 days, and then the queen lays eggs again, and you have a frame density that goes up and down every 24 days with the brood cycle. So we have published a paper where we show that we can actually pick up the brood cycle in a frame.
Are there any further questions?
Yes, there are 1 or 2 more.
More?
Yeah.
Of the colony's sound. And in my opinion, it is not specific enough. And I compare it with your heart rate. Your heart rate will go up and down substantially. It's a huge variation in your heart rate, but it is not specific to anything. You can have your heart rate go up because you've had too much whiskey or coffee, or you fell in love or anything like that. So it's not specific. And the bees buzzing, the microphone bees buzzing, in my opinion, is the same. It can change a lot. It will change a lot, but it's not specific to something. You can't tell the reason why they go up and down.
And would you see with the micro also the toot of the tutor of the queen?
If you're lucky.
The video I made, it was in the hive. There is a big
microphone.
Yes.
Sometimes it does. Sometimes it does. Sometimes it doesn't. So I've got a case here to show you. Where is it? It's here. So I've got an example here where the queen tooting.
There's also Dirk.
So the organizer, they asked me to give some concluding remarks. So I have set myself somewhere here in a corner and I wrote down a few things. It will be not on the venue, it will be not on the organization and not on the food, although food is very important, of course. I will keep that for the end, and but I can say that the start was already very impressive. So, but my comment on the organization and so on, I will keep that for the very end. And so, if the purpose of this day was to initiate the interaction with the beekeepers and the multi-actor forum members, then I think it was a great success. We never had this close interaction as we had today. I think my own talk was too short probably to tell everything about Be Good, but I hope that it was long enough to make you interested, that it will trigger you in future times to start or to continue following us and our progression that we make with this project. And then the Bee Quiz, it was really fun. So how I see it, there were 3 or 4 teams that ended with 12 points. There was one team that ended with 13 points. The crucial question was, how many beekeepers are there in tier 2 and tier 3? And everybody know that there is only one person that can answer that question. If you want to have that answer, you have to ask Kobe, of course. And guess who won the quiz? Okay. So, but I can live with that because at least one member of that team will bring a medal home to Ghent. Thank you very much. Then we had Dana and Wim. They presented the analysis of the beekeeper survey. They gave detailed insight in the outcomes of a Be Good study, and I think they nailed it. So they said that the profile of the beekeepers is a person between 18 and 91 years old. I can see that close to 91 years old, yes, when I give lectures for beekeepers, yes. 4/5 are men, 1/5 is female. Again, it's top on, 20% are professional beekeepers, 80% are hobby beekeepers. And then only 21 are users of hive monitoring technologies. And more important, that they found no differences in mortality between the group that is user of hive monitoring technologies and those that don't. But I think it will change over time when the Be Good data and the Be Good outcome will be, let's say, available, and we hope at least that it will make a difference of these technologies. So I can see also the categorization of beekeepers into 5 clusters. I feel very comfortable with the thing that they presented. It is really worth of publishing this outcome, and it contains a lot more hidden information than that was presented here. So the interactive session, I don't know how it went for the people at home with the digital version, but here in the live version, it was very entertaining. We had 2 groups here, and in fact 2 different styles. So the Kobe group, it was very Dutch, I would call it, with open discussion and discussion and discussion. Everybody can discuss and so on. And at the end of the story, they have only half of the topics that were covered. And then we have the Martin style, let's say, also a Dutchman, but nevertheless a completely different style. The magic word was voting. So in fact, when there was some potential of discussion, he said, we have to vote. So that's what we did. So there was no real debate, let's say, in our group. But what I saw also was that Raphael demonstrated that he has the skills of interacting with the beekeepers. He was our interactor, let's say, and he did a perfect job. So it learns us that many ideas pop up when we think on future of beekeeping and how digitalization can offer a solution. And then we had the information market, an exciting way to further connect with beekeepers and with the members of the multi-actor forum. As coordinator, I am convinced that we can double, even triple the number of stands. But I'm sure now that we have seen the potential of these information markets, that we will use this in future occasions, future activities of our consortium. So far, only about this, let's say, looking back was only on the program and the organization. But I think the success of this day was largely because of the beekeepers and the multi-actor forum members that attended. Your willingness to be challenged by us was amazing, and your individual communication skills were also very helpful. So many thanks for being here, your time investment and your active participation. So I understand now for the people that follow at home that the meeting will end here. We have a few more things to do with the people here, I believe. And then, but after today, then we continue with only the Be Good members. That's how it is. So many thanks. Have a safe trip back home and hope to meet you again. Thank you very much.